In this lesson we're going to look at how to represent a vector in 3 dimensions. So instead of having the 2 components this time, we're going to have 3. So let's look at this diagram here. The velocity v of an aircraft taking off can be written as this. So same notation, v underline or v in bold if you're on a computer, but you guys will be just writing in your notepads or your jotters, so just underline the vector v. And if you think about that on the kind of 3D coordinate system, then it's very similar to using 3D coordinates. The vector v, you go along 3, then you go up 4, and then finally the z part of it, if you like, is 2. So it's x first, then y, and then z. So this vector is 3, 4, 2. Now vectors can be represented in component form, but they also may be written in terms of I, j and k. Now I, j and k are unit vectors, I being in the x direction, j in the y direction, and k in the z direction, and each has a length of unit 1. So I, j and k, just like x, y and z in alphabetical order, and all with a unit 1. So if we're trying to represent this vector, we can do it v in 2 ways. We can write it as 3, 4, 2 in column format, or we can think of it as 3 lots of I along x, 4 lots of j along y, and 2 lots of k. So there's 2 ways of writing this, and you will see both notations in the exam. You need to be confident using both of them. So this can be rewritten like this, and that can be rewritten like this. In terms of properties of 3D vectors, now so far in the video lessons we've looked at properties of 2D vectors. Now you can apply those principles to 3D vectors. So everything you do with 2D, you can do with 3D. Except you're going to use 3 numbers instead of the 2. So if you look at the magnitude of a 3D vector first, on a 2D vector you used Pythagoras, so you square rooted and then squared the 2 numbers and added them together. The magnitude of a 3D vector is no different. The only difference is you square the 3 numbers, add them together and square root. And the reason for this is, if we look at this diagram here, and we concentrate on this line here, we get a better line to represent that. So if we concentrate on this part here, now that's really just 3 squared plus 4 squared square rooted. So it would be in essence 5, but that's 3 squared plus 4 squared. And then you've got your 2 here. So to get this here, you take your 2 squared and your 3 squared plus 4 squared, and you square root it all, and you end up with that. It's kind of Pythagoras twice, if you like. So you get your 3 squared plus 4 squared to get AC squared, and then you add on your 2 squared and you square root it all. If you don't really understand that, just square the number here, the number here, the number here, add them together and square root it, and you get the magnitude. Addition is exactly the same. You add the top components, then the second lot and the third lot, and you add them together. Subtraction, same idea. Multiplication by a number in front, same thing. 3 2s are 6, 3 3s are 9, 3 times negative 1 is negative 3. Negative vector, if you go in the opposite direction, then you change the signs. And the idea behind a position vector, to get from R to S, you do S take away R. This works in 3D coordinates as well. So all of the things that we've done in 2D work in 3D. The scalar, the section formula works in 3D, collinearity works in 3D, except you're using 3 numbers instead of 2. I would go and practice it and get used to using the 3 numbers if you haven't already.